Morning, everybody. Thank you, Chris. You can hear me okay? And yeah, oops. So thank you very much for organising this, Chris, and welcome everybody to the MTC's webinar, Automation Right First Time. I'm Nigel Knapp. I'm the Business Development Manager with our Manufacturing Support Services team. We're the customer-facing arm of the MTC, reaching out to manufacturers of all sizes to understand their challenges, and then we draw on the expertise of the MTC to help overcome them. We expect this webinar to last about 45 minutes, plus or minus a few. The key presentation on our part is being delivered by Phil Jackson. Phil is the technical specialist for the MTC's Intelligent Automation Group. He has enjoyed a career working in startup ventures to global blue chip corporations, in which time he has applied his skill set to developing many complex automated systems across industrial sectors such as biotech for waterborne pathogen detection and sensing technology for automation of condition monitoring. Phil has enjoyed many years of running large complex industrial research projects, building business cases and overseeing the implementation of new techniques and technologies. He's been with the MTC for 7 years and most recently delivered the MTC's Factory in a Box development. Phil Rawnston, who will introduce himself later, is a client of the MTC and has implemented automation projects, and we've helped him in that cause. And he's the MD of MRT Castings, and so Chris will introduce him more later. So the structure of the webinar, some of you may not be aware of the MTC, so I'll give you a brief introduction. And then it's over to Phil for the design for automation. Then please use a Q&A, as Chris said, because we'll have an exciting session with Phil Rawnston to go through a real live study as to what he's done. Open floor to ask whatever you wish. And we'll end just with a short video, and then we have got an offer to support the cause at the end. So briefly, the MTC is the Manufacturing Technology Centre. We're part of the High Value Manufacturing Catapult. Along with our peers, we are all geared to help any UK manufacturer be more competitive on the global stage. Amongst our peers, we are the new kids on the block. We've been open 9 years, but in that 9 years, we've now accrued 800 employees, all with the same mission to improve quality, cost and delivery performance of UK manufacturers, always with an eye on new technology. And we help you de-risk and accelerate those investments to get the best return in the quickest possible time. We have got a huge array of technology based just in Coventry off the M6 Junction 2, all the latest automation, robotics and 3D printing. And we are in fact the National Centre for Additive Manufacturing. So that's a very brief introduction. What I'd like to do now is hand over to Phil to run through automation the right first time. Over to you, Phil.
Smashing. Thanks, Nigel, for that blistering introduction. I should mention quickly that photo of me is pre-lockdown. I've gone a bit yeti since then, the spirit of honesty. But in any case, I'm just going to talk you through, first off, why design for automation is an important activity to undertake, and then go on to look at various different things that you need to consider when you're going through the process of designing your components and your products for automation. So crikey, that's an accelerated program. This is the first slide. Yes. So what's the point of the entire enterprise of design for automation? There is no question that automation has the potential to multiply your productivity and expand the bottom line. In fact, every country out there with a higher manufacturing GVA than us has adopted more robotics and automation than we have. There's one exception, and that's India, who they still have an awful lot of what I call manumatic production going on, but they installed twice as many systems as we did last year. So they have a plan, they're sticking to it, and we're about to be elapsed there. We have a bit of a shortfall in terms of automation adoption in this country, which is something I'll touch upon later on. Automation systems, whilst they can offer an enormous amount of added productivity, they also have the potential to screw things up in quite an impressive way. So I think there's an old expression, if to err is human. If you really want to screw things up, you need a computer. Kind of same goes for automation, but we'll talk a little bit more about that later on. Third point, getting it right. Getting it right is not as difficult as people think, because it seems like this sort of big what's the expression, a dark art, like a black box activity to get automation systems right and working to optimal productivity. As in fact, there's just a collection of tools and techniques that you can apply to getting it right. And it makes all the difference between a dodgy investment, a white elephant investment, and something that can really help to change the business and help you to grow. So it's just about applying sufficient diligence and sufficient diligence with the right mindset, with the right tools and the right techniques. I've got an illustration there on the right hand side. I like my stupid illustrations, but there's a badly installed robot crashing into something and costing lots of money, or a canning line below, which has been well specified, well installed, and creating a lot of value. If we move on to the next slide, please. So I'm going to elucidate on some of the points I've made. So you have a manual process. Somebody's putting value into something with their hands, and you essentially have dominion over your productivity. You have dominion over the quality of that thing passing in front of you on the workbench and how quickly those things move through. And as a side note, human beings are pretty good at dealing with stuff that arrives disordered in a box, jumbled up. Flexible elements like connectors and slippery parts like, I don't know, bits of onion or whatever. Irregular stuff, stuff with no indexing features to give you a key as to the orientation or location. And humans pretty good at stuff that requires dexterous manipulation, really fine stuff that you can do with tweezers. Move on to the next slide, please. Suddenly, if you install an automation system, that system is effectively in between you and your capacity to generate value. So you better make sure it works. There's another side note. There's a very familiar list here, stuff that automation systems are not particularly good at dealing with. Parts disordered in box, flexible stuff, slippery stuff, irregular parts, parts with no indexing features, and anything that needs really fine work. I just make this point because the whole backbone of designing for automation is to make sure that you have not just the right tool for the job, but let's say the right job for the tool as well. So if you're going to put something in the middle of your workflow, effectively between you and productivity value, you have to make sure it's going to be as robust as possible, and your solution is as reliable as it possibly could be. And I guess those last three slides are just to make sure that we're all banging our head against the same wall and understand that design for automation is a valuable activity because it supports automation, which can make your business more productive. We can move on to the next slide, please. Sean. Some of the conversations we have with people are around the fact that they have an existing product which is being manually assembled and they'd like to automate that process. And they've seen things on YouTube and out there on the internet, mostly sort of academic presentations or presentations by corporations that are trying to show off their technological prowess. And they make the argument, look, there's some really advanced robots out there. I know that because I've seen them. And I'll just talk you through quickly why the answer should never be immediately to go straight to the advanced robot use case. And I'll define that in a second. So on the left-hand side, I've got a very basic pick and place situation. The parts always arrive in front of the robot in the same orientation, in the same position. And the robot can fully constrain them, take them from the same place, undertake the same operation with a positive grip, and then put them back in a different designated fixed position. And that's pretty straightforward and pretty robust. On the right-hand side, there's a more advanced robot use case where parts arrive in front of the robot, disordered in a bin, and the robot has to basically sort this out. So the parts may be also differing as well. And there are technologies out there that will do that for you. However, if we can move on to the next slide, please. Let's look at what's involved in those two different situations. So on the left-hand side, you start the robot program, you execute it. Most of the ancillary parts around the robot, automation components you can get fixturing and clamping, are extremely reliable. It's a very mature business, and industrial robots are also extremely reliable. They've been around for a long time, and they're driven by the automotive industry, largely, who have extremely high reliability requirements. Whereas, let's look on the right-hand side at the advanced use case. It's not quite just a matter of starting a robot cycle running. there's a whole chain of stuff that you have to get right in order to achieve the some sort of return of value from the system. So you've got to acquire an image with a camera system of some sort, filter it so you get just the bits that you're interested in, recognize the objects, specific objects within that filtered image. You've got to work out the orientation, work out where exactly those parts are in space, and then you've got to start doing things like calculating your approach path so the robot doesn't crash into anything, calculating how you're going to grip it and what your strategy is going to be. And once you've done all that stuff, you can execute it and hope nothing moves between the time you've made your mind up about how you're going to do something and actually executing the cycle. And I put a list there of all the potential problems on the right-hand side. It just follows logically that every step that you involve in a process like this adds an extra degree of uncertainty. There's obviously stuff like variable light conditions, surfaces which have different appearances. There might be a bit of grease on the surface, so that they're not as reflective, or they're more reflective this time around because the polishing process is different in your production system. The lens gives some distortion, so you've got to digitally sort that out, which isn't perfect. There could be dirt, there could be occlusion, as in parts are being, the vision's being blocked by the bits. Some artifacts may not be automatically filtered by, however good the filtration system is. No such thing as a perfect system, or you can over filter so you miss stuff. I won't bother going through the rest of them, but you get the idea. There's even up to and including the fact that those sorts of systems notoriously can't collect things from the corner of boxes. And so what I'm getting to with this is, don't give yourself problems that you don't absolutely need to have. The business of automation or automation production reliably is to reduce the potential, obviously reduce the potential for things to go wrong, but reducing the number of variables that you've got to cope with. If we could just move on to the next slide. The reason that these systems have been developed and are sort of market ready and exist is because sometimes you literally have no choice. And I obviously completely understand that when you have heterogeneous parts coming into your production system. Let's say in the example on the right hand side, these are bits that nature gives us. You don't get to specify these parts with a data sheet. But having said that, in the example on the right hand side, even though we know all the parts are going to be subtly different colors, subtly different shapes, and they're going to be in different places, you would still make every best effort to limit the variables, which is why they've been grown in boxes and the fruit's always pointing down. So at least the machinery has a fighting chance of identifying a rough blob in a region that's kind of expected. So once again, if the alternative is just trying to send a robot into a completely unstructured environment in which fruit could be growing in any direction, you've got a hell of a lot more variables to try and cope with. So yeah, bottom line, it's all about trying to eliminate all the problems that that you don't need. Move on to the next slide, please. I did tell you I like my stupid illustrations, didn't I? The point behind this one is that the business of identifying a task that's currently being done manually, let's say a product assembly task that's currently being done manually, and putting a robot in the place of somebody, it's like a one-to-one swap, is rarely an effective way of doing things. In fact, I've never seen a case whereby it's been particularly effective. And the obvious reason is that humans and robots have entirely different characteristics. Whether it's your load capacity or the fact you have 10, well, most of us have 10 digits on, available to grasp things and manipulate stuff. We've got this, I put 7 hours a day uptime there, but, in my case, it's certainly coffee dependent, how much productivity you're going to get at any given point. But obviously humans are capable of doing fine, detailed, highly dexterous things and making decisions on the fly, making determinations about whether a component's slightly bent or something slightly misaligned and dealing with it. Robots, on the other hand, they can work semi-continuously. They've got a different operational range. They can't adapt immediately to things which are slightly inconsistent, wrong, bent, unexpected. So trying to directly port the same production process from a human to a robot is, obviously because of these characteristic differences, is a very inefficient way of doing things, and it's likely to result in a poor investment it's likely to result in a very ineffective automation solution. If we just move on to the next slide, I'm also going to go into a really kind of dumb example, but just to get the point across. Here's a human being washing a car, not an uncommon sight. So you think, well, we need to automate that process, right? Because we could lower the cost of washing cars. Well, if you do it this way, you can't lower the cost of washing a car. That'd be an incredibly slow way of doing it. With all the technology, ancillary technology, you'd have to connect to the robot to pick up all of the features on the car, and how slowly you do it. Whereas if you've actually done a proper task analysis and understood what you're trying to achieve, you're going to end up with something a little bit more recognizable, which in this case is something more like a special purpose machine. So what I'm getting to is it's all about understanding the tasks that you need to undertake and breaking them down and putting them back together again for an automated circumstance, for an automated production scenario. Let me just move on to the next slide. And once again, I'm gonna drum into this one a little bit more. So what we'll do when we go into a production environment and look at automation, look at the most efficient way to do it, is try and strip away all of the sort of legacy, let's say fingers and thumbs human processes that exist, and try and get down to exactly what we're trying to achieve. So as I say, if a human being would normally screw something in with a screwdriver, you don't just give a robot a screwdriver. You look at exactly what you're trying to achieve. So top level, what we're trying to achieve is some way of fixing this product together. Okay, how are we going to do that? What's appropriate for automation? The example I've given you here is that a manual process involves several human steps. So, I don't want to have any arguments about whether or not the milk goes on the tea bag first or the other way around. I know this one can get really contentious, but so in general, if you put the kettle on, you get yourself a mug, you get the tea bag into the mug, water into the mug, agitate it in some way, get the tea bag out, milk in, so I think we're all fairly familiar with that process. But then if we look at the middle, what exactly are we trying to achieve? Let's forget all the human steps. What are we trying to achieve? Well, at some point, the tea and the hot water need to meet each other and get agitated. And at some point, that stuff's got to end up in the cup. And the milk's got to end up in the cup as well. And at some point, that stuff's got to leave the system. It's got to be handed out to whoever wants the tea. So if you look at the fundamentals and then build them back up again for an automated circumstance, you're going to end up with something a little bit different. So I think we're all familiar with those tea machines that dispense something that tastes a bit like burnt water, but quality aside. So things are done entirely differently. With those machines, they acquire the tea bag in the cup. So they've now dealt with one of those problems in the supply chain. The tea bag comes inside the cup. The inline water heater is activated. It jets the water into the cup, which has a dual function of agitation as well. Milk powder is mixed with water, and that's jetted in. I'm sure there are a few grimaces out there, by the way. It's just horrible vision of automated tea. And at some point, the cup is dispensed, and there has to be an in-process cleaning routine that the system goes through. What I'm getting to here, if I haven't already hammered the point a little bit, is that if you were to just take the original process, the original manual process, you're going to end up with a dotty situation whereby you've got something resembling a robot arm in a kitchen, lifting up a kettle, pouring. I mean, it just doesn't make any sense. And it's clear it doesn't make any sense because that's not the way it's done. So that's what I mean by task analysis. It's breaking down the fundamentals and understanding exactly what you're trying to achieve, and then putting it back together again for an efficient automated circumstance. If we move on to the next slide, please. So I'm going to move on a little bit. There are questions around what kind of machine that you might want to use for your automated process. Now, I just want to mention here, if you approach a robot supplier for your automated solution, you're going to get a robot. And so one of the things that I have conversations with people about is making sure that you've done the task analysis and you understand what your business case is, so that you can choose the right kit, and you go in there as the intelligent customer, knowing what kind of characteristics you need. Robotic systems, terrific. If you've got a relatively low production rate and you need that flexibility, maybe every product, you have an aspiration to make every product subtly different or customized, or you want to reuse that asset in the future to do something different. That may well be the answer for you. However, as production rates go up, you might want a special purpose machine with which gives you a particular configuration but not full flexibility of your product. Or if you've got things whistling through at a rate of knots, maybe it's just an actuated tool. Literally, let's say something like a punch that makes thousands of drinks cans, every hour or so. So there's a different business case behind all of these things, and it's crucial to understand what your margin for value is, so that you can look at, and all of the other characteristics that you need, so you can look at the right type of equipment to choose. Move on to the next slide, please. So I'm just going to round up the thing about that was really about automation systems as opposed to product design. Product design is the next section. But I just want to round this up by saying important things, understanding what value your system automation can bring you. It's crucially important so that you can make sure that you specify the equipment in such a way that you don't end up blowing the business case out of the water and having a rubbish investment. Understand what interactions have to happen. Yeah, that's the product's eye view. That's making sure you have taken into account absolutely everything that needs to happen to those input materials and working for that, not working for an existing process that involves people. Obviously, you can establish which different technologies you'll need based on that, and reaffirm your business case based on some ROM costs. There may still be a business case, even if it's not for automation and you have somebody with smart tools, or there's still a manual part in the process. So all of these things need to be calculated. I've talked about stuff arriving disordered in bins, but you can always address your supply chain and try and deal with those problems. It's much, much quicker and cheaper to get your suppliers to install a bit of automation such that stuff that comes singulated off a conveyor belt on their site is packed up in a nice matrix container than it is for you to sort the problem out downstream when you've got a box full of jumbled up stuff. I'll talk a little bit more about that in a second. Understanding what process variables, I've talked about limiting variables, but what process variables do you have to control? That's going to feed into the kind of system that you need and the kind of control system that you want and how you're going to specify it. And writing a robust specification is incredibly important, because it's a contract. And incidentally, something we can help you to do, whether it's to review or to co-author it. Everything really in this day and age should be run through in virtual space. There's some wonderful tools out there that help you make absolutely sure that what you're about to cut metal to create will actually do what you need it to do, whether it's the virtual commissioning stuff that effectively simulates a control system, or whether it's the capacity to be able to check a robot system in virtual space for its reach capacity and cycle time. All of that stuff's available. So checking, and there's an illustration of such a study on the right hand side. Use these tools. They can avoid costly mistakes and they can really steal a march on time. Basic automation principle: if you don't need to move something about, don't do it. So design for automation is quite a there's an awful lot to the subject, and I'm going to give an overview rather than any an awful lot of depth on any particular part, but that's one of the overriding principles. If we can move on to the next slide, and I realize I might need to accelerate. So indexing features. Once again, machines aren't inherently clever. Obviously, you can do things to try and make them respond to the product or environment in some way with clever control systems. But once again, if you don't have to make it complicated, don't. So nice indexing features on all of your parts to establish positive repeatable grips on things. Yeah, absolutely crucial. Simplest way of making sure you repeatably pick and place things or manipulate things. And there's an example of a robot picking up a tote box there. By the way, I should mention in the next couple of slides, a lot of design for automation principles are very, very similar to just great design for assembly principles in any case. So it's good practice whether or not you're putting a robot in. It's important to remember, if you are putting these indexing features in, any features associated with helping the robot to assemble things, you need to control those features. You need to make sure that they are toleranced, and you need to make sure that your supply chain has a quality system in place to allow you to to maintain the consistency of those indexing parts. Lead-ins, where possible, you really want things to self-locate and to nest. Robots you can consider to be completely rigid systems. So we'll move on to the next slide and I'll talk a little bit more about that. Self-locating and self-aligning features are great anyway. Oh, it's not, I beg your pardon, it's not the slide I thought it was. But yeah, they're great. They're great principles in any case. But as I say, things over time will drift. They will move. So give yourself every possible chance to absorb any misalignment. I will talk in a second about how you allow a robot to soak up misalignment without resorting to really advanced vision systems. Grip type, once again, I think most of this stuff is fairly straightforward and fairly well understood. But you might see, once again, out in the world of the internet and you know, whether it's YouTube or marketing materials, some grippers that can pick up all sorts of things. So on the right hand side, that's called a jamming gripper. It sort of basically morphs its shape to surround almost anything, and it can pick and place almost anything. The problem is, you don't know where that part is within your grip. You know, it's not an indexed repeatable grip. So you've given yourself a problem. You need to work out where that is. And what's going to happen is if you pick it up and it's in slightly the wrong position, you just carry that error over to wherever you put it down. So if your grip isn't kind of self-aligning, it's not sort of retaining and self-aligning, you just carry errors over. And the only alternative to that is having a really expensive advanced vision system to try and give you some sort of understanding of where that part is within the grip. The middle image is some converging parallel grippers. Once again, you see them quite commonly. However, clearly, if parts can move in your grip over, let's say, 10,000 manufacturing cycles, parts probably will move, and then you might get a crash, and you might get, which is to say, you break the gripper, you break the robot trips out, and you lose time. Much better, and I'm moving from right to left here, much better is to consider with every component having a fully constrained gripping features. If we could just move on to the next slide, please. A little bit more about that. So sorry, and this is a roundabout way. So I'll finish off the fully constrained thing, but you know, anything that allows you to pick up something repeatably with controlled features, such that as you grip it, it will position itself in a predetermined position relative to your gripper. That's what you want. You want control of the parts. Compliant heads, you know, we use them to soak up misalignment. So there's an illustration of a grinding process on the left-hand side, and a compliant head being used to exert a given force against a radial force against the part. These parts or these components, many of them work on the basis of a pneumatic pressure signal, so you can say how much deflection is allowable and in what axis. So you can soak up angular misalignment, or whether it's compressive or torsional, as I've illustrated there. They're very, very useful components for giving yourself a set amount of possible, what would you call it? Possible movement between the robot and the parts that are being fitted together, because, as I say, the robot has no imagination. Consider it to be a completely rigid system, and so 0.5 millimeter misalignment, the robot is just going to drive one part into the other and either fault out or bend things, which is why this stuff's important. And next slide, please. I'll whistle through these. Another thing to consider when you're automating: am I going to put my components on the robots and the process equipment is going to be stationary, or the other way around? Do I want to move around the process equipment? And the stuff you want to consider there is all the services you have to move from the base of the robot to the flange of the robot, and those service lines are quite expensive because they've been designed to move around a lot and withstand a lot of different cycles. You also have to consider stuff like how much power you need to get to the flange of the robot if you've got a tool on it. You know, what are the weight of your components? So there are a number of things to think about there, but it is a consideration. If we can move on to the next slide, please. Fixings, there are more things to be considered than this, but the easiest and cheapest component retaining method, and this is the reason we see so many plastic clips out in products now, these are the easiest for robots and automation systems to deal with. Unlike screws, which are, they're fiddly, where are the indexing retaining features on, let's say, a flathead screw? Quite difficult for a system to robustly work with or repeatedly work with. Ultrasonic welding is a terrific option for putting things together as well, as long as you don't have to subsequently take them apart again. As long as it's not a serviceable container, let's say. And if you have to use bolts and screws, they are available with proud driving surfaces, which the robot can easily pick up and manipulate and get a positive purchase on. Move on to the next slide, please, Nigel. Connectors. Avoid flexible connectors wherever possible. They're extremely difficult to work with. Instead, consider board-to-board connections or jumper strips, which have been made to be rigid, such that you can pick them and place them without things moving around too much. The other alternative, of course, is to put rigid plastic or other material webbing around the flexible connector, so that it all stays in the right plane, so you can pick it and place it without things moving too much. Next slide, please. Part marking. Instead of trying to pick and place labels from a reel, if you've got complex topography on your component, laser etching is very, very good. I put continuous labeling machines there, but they're really only much good for components with flat surfaces, without pockets or undulations. And inkjet systems are now very, very good. So worthy of consideration. By very, very good, I mean you can actually print full color over some quite interesting surface topography, and worth looking into. If we can move on to the next slide, please. Last couple of slides. Stackable matrix trays, and I already talked about the possibility of trying to deal with inconsistent part delivery or chaotic part delivery, let's call it that, with parts in a box in the supply chain. So if you can I've come to an agreement and issue them a stackable matrix tray like the one illustrated on the left or the right there, so the parts are always orientated in the right the right orientation in fixed places, then you've effectively got rid of an entire automation headache that you would otherwise have to have dealt with. As I say, the chances are when they manufacture the parts, they are singulated and orientated, and what happens is they just drop off a conveyor belt to a bin typically, and then you have to deal with the problem downstream. Move on to the next slide, please, Nigel. So I realize I'm running over time, so I do apologize, but so I'm going to summarize with this last slide, ideally with a new product introduction. And I know that's not the reality in a lot of people's lives, but if you're introducing new products, the product and automation tools should be designed at the same time in a multifunctional team. The antithesis of this is unfortunately the typical situation where you get someone designing something beautiful, throwing it over the wall to someone who's got to, the manufacturing engineering, someone's got to work out how to put it together, who then throws it over the wall to the people who've got to assemble it. That's clearly going to introduce some issues into the efficiency of production. But no, the bottom line is make sure that something's automatable, or the assembly of something is automatable by developing the tools and the product at the same time. I've talked about making sure the automation critical features are controlled in the supply chain. That's just specifying parts on drawings which have certain tolerances and holding a quality system. Holding that to a quality system, anticipating product changes down the line. Clearly, if your product is going to change at some point, you need to make sure that you have that flexibility within the automation system that you specified to deal with it. It sounds like an obvious point, but it's amazing how many people make that mistake. The business case, that should be fully understood. One thing is if it feels like it's an opaque thing to you, it's the sort of thing that we can help with. But it's crucially important because this is all about the bottom line. Ultimately, it's crucially important to understand what value you can achieve and how far you are towards the margin of that possible value with the system that you're trying to specify. Virtual methods I've talked about, my goodness, the tools are available, exploit them. It's a gift. And road mapping, automation isn't something you can just, this is an entirely different topic. It isn't something you can just adopt tomorrow. There are lots of different things to consider, and amongst which are things like culture and your infrastructure and your future future product offering. So creating a roadmap and having a long-term view is absolutely crucial to making this work properly. If you don't have the luxury of introducing a new product, which is like essentially a greenfield sort of blank sheet of paper scenario, you need to understand the cost of redesign for automation, because at some point, the cost of either carrying on as you are with increased competition from outside, or the cost of putting in really advanced automation to stoke up the fact that your product hasn't been optimized for less advanced automation, has a crossover with the cost of redesign, retooling, redesign of the whole product. So you need to understand where that point is, so you make sure you don't tip over it. Determine whether or not you can actually do parts of your assembly with smart tools, or don't just think about robots. There are lots of other things to consider, and there's a business case behind all these things. And the last 2 points are really just about slowly understanding what your product should look like to be optimized for automation, and then you're in a position to be able to slowly iterate when you make product revisions and put the different features in that you need in order to get to a situation whereby you have a product that's been optimized for automation, instead of facing just like a enormous step cost to retool everything and redesign the products. Road mapping, again, crucial. Once again, I apologize. I think I've run over a little bit, but that was the last slide I've got. So I'm going to hand back to Nigel, I think.
Yep. Thank you, Phil. Thanks for that. There's a lot of content, and well done to get it in the time, plus or minus a few minutes. Couple of questions. You mentioned towards the end the design for manufacture, design for automation. What if I only sort of make to print? Will that weaken the business case?
Not necessarily. I mean, because the automation can be can be applied to different parts of that scenario, which aren't necessarily associated with the core business of putting together a custom product. So it might be that it's materials prep, it might be associated with quality. There are several other things that you could consider. And once again, if you're building to print, don't forget, you can take presumably you're talking about a situation whereby someone's given you the design and you're just building it. Is that what I'm understanding from product?
Yep.
Yeah, there's no reason not to then apply stuff like smart tools to the product assembly, on the basis that you can take the tolerances straight off the customer requirements and drawings and pump them into the smart tools to ensure you have that level of quality and repeated output.
Okay. I guess you could also climb the wall and maybe go and talk to the customer in the first place, see if he could redesign it himself a bit to help you.
Yeah, absolutely. Yeah.
Second question, last one before we move on. If I was going to put an automation system in, I'd call on the services of a system integrator. How much do I need to know to make sure I'll get the best solution for me?
That's another really good question. Actually, you need a commensurate understanding of what all of your business drivers are. Ultimately, as I said before, it's about the bottom line. So what does what's your product market look like in the future? So you're going to have to, at some point, specify to the system integrator what kind of throughput you need, what kind of flexibility you need, and also what kind of price point it needs to come in at as well. So if you don't understand what's achievable, then you're not going to be able to specify and procure something that's going to make sense for you down the road. So I actually have an exhaustive list of this stuff, but yeah, it's your production projection, and other issues like uptime, quality, noise, allowable noise output, energy usage. So all of those factors that are connected with your business.
Thank you. We might get a bit more of this from Phil Rawson, who's applied integration through integrators, etc. So thank you for that. And now, talking of the second Phil Rawson, I'd like to hand over to Chris to introduce Phil and take on the next section for a Q&A. Over to you, Chris.
Super. Thanks, Phil and Nigel, and particularly Phil, for some of those great analogies and imagery to get some of your points across. Hopefully that's resonated with some of the delegates this morning. But as Nigel refers to, we are delighted to be joined by Phil Rawlinson, who's Managing Director of MRT Castings this morning. So welcome, Phil. And just to introduce your business, you're a die casting, machining and finishing specialist. And to spare your blushes a little bit, you're almost a little bit of a with a track record of winning awards, having won the Queen's Award in 2016 for exporting international growth exports, but also actually this year you won our Manufacturing Matters Award in the South for your role in producing components for critical care ventilators and ramping up your production for that demand. So and that award's all been about some of the credits that our sector's been able to role it's been able to play in the pandemic. So hopefully you could kick us off a little bit, Phil, by sort of giving us an overview of the automation that you successfully implemented at MRT.
Yeah, thanks for the introduction and thanks for the sales pitch, Chris. That's appreciated. So yeah, as you say, we're a foundry based down in Andover in Hampshire. And we're producing aluminium die castings and machine components for a massive range of different industries. We're supplying, as Nigel was just saying, we work to print. So we make components on behalf of our customers to their designs. So we don't get to influence those designs, directly. We make what they ask us to make, but we're working for customers in the medical sector, aerospace, defense, electronics, marine, bit of automotive, you name it. Mainly small and medium volume, so not so much on the sort of high volume automotive type stuff, which makes it a bit more of a challenge for us in automation because we need some very flexible solutions. We don't have individual assembly lines that are producing a single component. We have a fairly mixed resource of manufacturing capabilities. So producing aluminium die castings and CNC machined components, been established since 1947. And we're supplying all around the world. So in normal circumstances, about 60% of our parts are exported. So die casting is a very competitive market, it's a very global market, so productivity is key. So like most manufacturers throughout our history, really, we've been looking at what we can do to optimize our productivity by investing in the best machinery and increasingly now automation and obviously people. So over the years, that means that, if you go back 30 years, our die casting machines, the operators would have been ladling metal, by hand from the furnace into the machine. They'd have been then, spraying the die with a hand spray gun. They'd have been extracting the casting from the mold with a pair of pliers. For the last 15 years or so, we've been moving to automating that. And as you'll see from the artist's impression on the slide there, we've just built a new foundry. It is actually finished now, and we're just moving our die casting kit in there, and all of our die casting cells in that foundry will be fully automated. So they now have robots ladling the molten metal from the furnace into the machine, robots spraying the mold tools, and robots extracting the castings afterwards. But we also have a large CNC machining operation. Now, the CNC machines in themselves are obviously automation, and increasingly we've been using things like twin pallet machines to cut down the loading time. But yeah, a few years ago we said, right, it's time to start looking at robot loading now to increase our productivity further. Principally, actually looking at running for unmanned hours. So we typically run single shift, but we've got an awful lot of expensive kit that's sitting there not doing anything at night. And night shifts at the time, didn't look particularly attractive economically, and finding the right skills for that. So we wanted to look at robots for loading our CNC machines and increasing our working day. But it's a minefield out there. I think as other Phil alluded to, you can go to a robot salesman and they'll sell you a robot, but actually you need to understand a lot more of what's around that. And so we partnered up with the MTC a few years ago for a project to introduce robotics to our machine shop, and that's been really effective. And it's certainly made us more productive. It's made us more agile, and part of that agility has helped us over the last 6 months through COVID, because our largest customer makes ventilators. And so in March they suddenly hit the panic button and said, "Can you double your production in a week?" And we went away and thought about it and went, well, okay, we'll we'll think of something. And then they came back a week later and said, actually, can we increase our production 5-fold? So yeah, we've had an interesting year. We've increased production of ventilator components from 60 parts a week up to 600 sets of parts a week for ventilators, and we make 21 components in every one of those ventilators. So we've had a busy year, but certainly automation has really helped us in that sort of that period of adapting and increasing our output. So yeah, that's been our journey recently anyway.
Super, and it's really great to hear how automation's played a role in some of your sort of more recent successes, and also the wider significance of the work and components you supply do. But Phil, the other Phil, mentioned a lot of the considerations and analysis before undertaking a lot of automation. It sounds like you're pretty far down that track now, Phil. What was the kind of, how important was that for you, and what were the key considerations maybe in thinking on some of those?
Yeah, I think, you know, it was something we've been very conscious of for years, of, you know, the need to take that next step, you know, from using machinery to using robotics for the next step of automation. You know, like Phil alluded to, it's a journey, and in some cases, you know, special purpose machinery or something is a much more appropriate automation than a robot. But we'd sort of gone as far as we could down that route, and then it was looking at, well, yeah, but there's all these tasks that people are still doing in terms of loading and that kind of thing. And actually, if we could use robotics for that, then we could increase our working day, we could increase our consistency and our, you know, and our quality, and free up our people for you know, doing more interesting work. So I think what happened was, we sort of, you've got to understand, you've got to have that solid foundation. You've got to understand your process of what you're actually trying to achieve. Phil explained that automation doesn't cope well with chaos. So if you've got a chaotic workshop or a chaotic presentation of parts in your manual environment, robots aren't going to work for you. Automation is not going to work for you there. So you've got to get yourself organized first, have a stable foundation, understand your process, and then really identify what you're trying to achieve with automation. So in the example I've just used, it was that we were trying to run our machines at night, unmanned. So actually, we were going to lots of sort of robot integrators, and they were saying, oh yeah, we can do this a lot faster for you, or we can improve the quality. And it's like, well, actually, that wasn't what I was trying to achieve. What I was trying to achieve is running unmanned. If I'm still going to have a man standing by the side of it, but it's going to run faster, that doesn't open up that time that we were looking at. So be very clear about what you're trying to achieve from automation, so that when you're then explaining that to potential vendors, you don't get sidetracked, because it's very tempting. We're all like kids in a sweet shop. You go and see a robot demo, and it's fast and it's shiny and it's whizzy and it looks great, and it's very easy to sign on the dotted line, and then you realize that you've bought something that actually didn't do what you needed it to do, and perhaps didn't complete the whole process. So you've still got a lot of offline operations that you're doing alongside it, and that defeats the object. So yeah, I think the key is really sort of understanding that process.
Super, that's some really good advice there, Phil. But I guess the bit of advice I'd be interested in hearing your thoughts on is, what would you say to any manufacturer that's sort of been thinking about it, or maybe wanting to implement automation, but has a bit of anxiety around some of the risks at the moment?
Yeah, I mean, it's easy to overthink it. It's easy to find a lot of reasons why it's not going to work. And to some extent, you've just got to take the plunge and get into it. What we did is we invested in automation before we needed it. So essentially, in my machine shop, we had 20 CNC machines, and I said, right, we're going to take the plunge. We're going to buy an additional CNC machine, and we're going to automate that. But I wasn't specific at the time which parts we were going to put through that cell. And that's where I actually ended up working with the MTC. And we said, look, guys, come in, have a look at all the different components we're producing. All I need to find is 5% of those components that would suit an automated cell. Because there's round parts, there's square parts, there's parts from billet, there's parts from casting. What's the low-hanging fruit that we could group those parts together and put it in a simple robotic cell, just to gain experience and dip our toe in the water. And so we probably did it 6 months before we needed to. We created spare capacity to do that. We weren't interrupting the line. So the business risk was the sort of 6 months of time and the investment in the extra machine that we sort of allocated to that, but we didn't instantly expect it to kick straight in. I think if you integrate it into a line that's already running full pelt and a team that's already stretched, you're going to trip over pretty quickly. So yeah, I think you've got to that first introduction to automation, you've got to do it alongside your day-to-day activities until it's mature enough to integrate.
So that is something we tend to hear from members. Actually, you mentioned about low-hanging fruit, and I think typically we hear that, you know, starting small to reap the benefits on smaller scale projects, and then take those baby steps upwards from there, really, as you say.
Yeah, and the steps are really quick as well, because once you've taken that you know, you've turned the water, and your team, who will initially be skeptical, you know, they might be excited by the new opportunities, but there's always going to be doubt. Once they actually see it, and once they realize the benefits, suddenly it accelerates the whole process, because you've got a lot more energy and enthusiasm behind it, and you've broken down some of those fears. So yeah, start simple, but you know, it can accelerate really quickly once you gain your confidence.
Super. I was going to touch on that, Phil. You've kind of really cordoned me off a little bit on you touched on the role of your people and getting them on the journey with you. So I guess if there's anything to say on how you got your staff to join you on this journey, but also one of the barriers we often see is kind of digital skills or maybe reskilling of current staff to work a lot of these robots or automation projects. How have you managed to cope with that particular challenge?
Yeah, I think it's always a fear, isn't it? And people see, you know, there's that myth out there that, you know, robots are going to take people's jobs, and so you have to allay that fear very early on. And if that's what you're intending to do with it, I would suggest, you know, it's a recipe for disaster. You know, if you can introduce automation when your business is growing, and use it as a tool to accelerate that growth, the employees see it as a positive. And that's certainly how we've always tried to present it. If you're going to bring the robot in and lay half a dozen people off the next day, then you're not going to get an awful lot of support. But if you can bring those people with you, then obviously it creates great new opportunities for them. It's career progression for them. It's skills development for them. And certainly our guys have really embraced that. In terms of the digital skills, I think the risk is that some people go, oh, our guys don't know anything about robots, so therefore I'll get a robot specialist in to look after the robot. The thing is, yeah, those robot specialists might know everything about how to make a robot dance around the floor, but they don't understand your process. Actually, better is to take the guy that's been working on it manually, understands the process, understands the machine that you're integrating with, and actually the robotic skills are pretty simple. You know, a few days training, most of them, they're very intuitive in their programming. If you've got bright young people, they will pick it up fast. But I think it's a mistake to say I need automation specialists. I think you need to maybe get some external help for that. But I think growing those automation skills from your existing team is from our experience, the most productive way of doing it.
Great, super. It's good to hear, you know, an investment both in innovation, but actually your people along the way as well. But yeah, thanks for bringing that to life, Phil, because, you know, a lot of the considerations that Phil mentioned are all very, very important, but actually thinking of somebody that's brought that to life and the strategy to life at a business is really important. And I guess you mentioned the external help. I guess that's a good segue back to you, Nigel.
Thank you. Yes, thanks very much, Phil. That's brilliant. It's nice to see an insight in the real world, and I'm sure if others have got questions, they can fire them back to Chris, and you'll hopefully be on hand to answer them if you need to. Just a couple of slides just to finish off. Very short video, and then an offer. So I'll do the other way around. Do the offer first. So what we're saying is, what Phil Jackson, the first presentation, really trying to help companies out there. We've got the offer of a one-day design for automation. So it's for the likes of Phil to come into your business, to have a look around, to say, okay, where is the 5% that's right for automation, or how could automation help your business become more competitive? If you would like that to happen, we can happily do that. It's a first come first serve basis. Please email us at the email address there, mss@the-MTC, by Friday the 27th, and we'll gladly set up a meeting as soon as we possibly can within the COVID constraints. We are still doing site visits. We just need to follow the protocols to make sure that we're all safe, but we're happy to do that. And just to end on a very short video, just to explain a little bit more what we're doing.
We can deliver value to businesses quickly.
Working with clients, strengthen their businesses.
Using their challenges and the technology that's right for them.
£50 million worth of the latest manufacturing technology.
Fresh thinking that you could not access any other way.
Doing things out of the ordinary is not out of the ordinary for us.
Working with the MTC has been fantastic. I believe this is a smart approach to business.
We've turned over 30% more orders. We actually haven't employed anybody else.
We've managed to double our turnover in a period of 2 years without increasing our overhead costs.
We focus on helping Great British manufacturing get even better.
So thank you for that, and back to you, Chris. I think we finished just within the hour, so over to you. Thank you very much.
Super. Thanks, Nigel, and thanks to Phil and other Phil for all your contributions this morning, and thanks for some of the comments coming in there regarding the presentations. And yes, there will be a sharing of how to get in touch with the guys at the MTC along with their slides. And if you did have any follow-up questions that you specifically wanted to ask Phil from MRT, then we're happy to make introductions in that vein as well. But I think in the essence of time, I thank you all for joining us, as I say, and let you crack on, and we'll end the session there. But thanks again.